Hi everyone, welcome to Keras Nights, a show about making deep learning easier with Keras, and a show that gets you ready for the Keras Day that's happening on the 30th of September. Today, I'm joined with amazing guests, including Daisy Okacha, and Daisy is a data engineer at Equity Bank. Hi, Daisy.
Hi, Ngesa.
How are you doing?
Um, I'm doing well. Thank you so much for having me tonight. As you can see, it's been a long day of work. I'm still at the office, but I'm really stoked to be here tonight.
Me as well. I'm so excited. I really can't wait for what we have today. Do you have the plan for the day?
Yes, I do. Thank you very much, Ngesa, for that introduction. As you've heard, I'm Daisy. I'm a data engineer, and I work with GDG Nairobi to organize events around machine learning. Tonight, we are super stoked to bring to you guys Keras Night, an ML podcast by GDG Nairobi. And the program for tonight really is we'll be introducing to you our main guests for tonight. That's Vanya and Goose. After which, Vanya will talk about Cargolex programs and her experience in the field and just encourage and reach out to women in the community and empower them towards taking part in machine learning projects and the community as well. And then Goose would also be taking us through Keras Core. And finally, would have a mini panel session where we'd ask Goose questions around Keras Core, general questions, and just how the community really can be involved in this. I hope you guys are excited. So stay tuned for more. Um, Without much ado, I'd really like to call upon Vanya. So Vanya is a promising data scientist based in Edmonton, Canada. She has worked on machine learning projects with special emphasis on forecasting. Her passion for programming led her to the field of data science and web development. She runs the GDG Cloud Edmonton, where she loves helping her community improve their technical skills, like how she did in the beginning. She also likes to exercise outdoors, watch Netflix series, and cook Mexican food in her spare time. It's worth noting that she wants to empower adult women, especially family women, to make the transition to technology. That's very powerful, Vanya. Welcome to Kara's Nights. We are very stoked to host you.
Hello, everyone. Thanks, Engesa. Thanks, Daisy. Nice to meet you both. I'm so excited to connect with the community in Nairobi. I'm Vanya Hanatiuk, GDG Cloud Edmonton organizer and woman tech maker. I want to extend a special invitation to all my curious, bold, and persistent sisters developers to learn or upskill their abilities in machine learning or deep learning. Check the GDG Nairobi's YouTube channel and the Machine Learning Study Jams playlist with curated content from machine learning beginners to deep learning. Afterwards, expand your portfolio with machine learning projects with industry experienced mentors at Kaggle X BIPOC mentorship program. The program is looking to increase representation for underrepresented groups in data science, and the African community represents a large number of developers. This program recruits mentors throughout the year, and stay tuned for the application for the end of the year. I'm going to drop in the chat the link for the website so you can stay tuned for the latest updates. Thank you so much.
Thank you. Thank you very much, Vanya, for that second introduction. And just to plug the people on the call really to the Kaggle BIPOC program. It's very impactful. Secondly, I'd really like to call upon Goose to the stage. So, as we all know, Goose is a machine learning developer advocate in the Google AI team. His main passion is making machine learning easier for developers, really. As of late, he's been working with large language models like the Palm AI, Mecha Suite, and Vertex AI Gen Studio. He also works with TensorFlow Decision Forests and Simple ML to make your business data shine, and with Keras Core to help you create ML models. Welcome, Goose. Thank you very
Hi,
much.
of course. Hi, everyone. Glad to be here. Should I just start direct like this? Yes. So let's go. Hi, everyone. Let's talk today a little bit about Keras Core. Is the presentation already? Yes.
Yeah.
Thank you very much. So let me change my screen. Thank you very much, everyone that are here. I hope you can learn something new or improve whatever you know already. As they told me, I'm Gus. I work as developer advocate on the Google AI team. My job is to help everyone use machine learning the best way possible and solve their problems with that. Today, I'm going to talk about Keras Core, which is a machine learning layer or framework that you can use to build models in TensorFlow, JAX, and PyTorch. So it's a very cool new thing. There's a link for all my social and contact stuff on the link tree there. You can take a look on that later if you want to follow me for this kind of content. So let's try to understand a little bit how is the ML landscape as of today. Approximately 60% of the market use TensorFlow. The other 40% use PyTorch, and we have some people that use JAX. They are not like super large numbers, but they are very important research labs. So they are the people that build very advanced models, including, of course, Google, Midjourney, Cohere. So these people they use JAX and they love it. And if we think about the frameworks, each framework have their own pros and cons, but they have more than that, they have their important value. That's why their users use that. But the challenge is that whichever framework you decide to use, you kind of silo yourself and you are then on that framework. You have to, if you build your model using TensorFlow, it will be hard to share with other people that are using PyTorch, for example, right? That's a problem that we've all been through. So it's a little bit tricky. So this is how it is today. And what's Keras? So if you didn't develop for TensorFlow, Keras is an API, as they say, designed for human beings, not for machines. So the idea is to be very easy to understand what's going on. You can read the code and kind of have a good idea of what's being done there. The API try to be as consistent and simple as possible. The defaults are usually very good, so you don't need to keep adding lots of parameters to stuff. The defaults are usually very what you expect. And the TensorFlow framework, the suggested API we had since TensorFlow 2 is the Keras API, and that has been used by a lot of people, and you can train your models on very large clusters with GPUs, GPUs. We have Google internal teams using these, many people outside using this. So Keras is absurdly popular in that sense. And this is kind of, it gives an unfair advantage because it makes your life way easier. So it makes easier for you to develop machine learning models. And here is an example of how to use the TensorFlow plus Keras. This is, if you ever did any TensorFlow in your life, this is maybe the first code you read, right? So the idea here is we're training an MNIST model. I'm not going to all the details here, but I would like for you to pay attention that what's happening there. I'm loading a data set, right? Third line over there. First line, I'm, of course, importing Keras. And then I'm loading a data set. And then I'm creating a very straightforward model, a sequential model that has an input layer, convolutional, then a flattened dropout dense, right? Very, very straightforward. And then I call compile and fit. That's it. When I do the compile is when I define the loss function and the optimizer and some additional metrics. And when I call the fit method is where the training happens. I can also call the evaluate method on my test data set to see how well the model is doing. This is a very straightforward Keras usage. This is the first class, right? First class of Keras is basically this. And now what's this multi-backend Keras, or you will see later that the name also known as Keras Core. It's an implementation of Keras that works with TensorFlow, JAX, PyTorch, and NumPy. NumPy is basically for inference. It's not really for anything. It's mainly for testing, but it works with NumPy as the backend. So what the wording I'm going to use from now on is Keras API, and the TensorFlow, JAX, PyTorch, we will call those backends, right? So those are the backends. That's an important nomenclature I'm going to use. And the cool thing is, if you any Keras model that use all the built-in layers from Keras package is compatible with all frameworks at the same time. They all work. You don't need to change anything, and you can run your model in any arbitrary framework that you want. So if you can just, we'll see many examples of how to mix and match and how to use the pros and cons of each. And the idea is that you get the best of all worlds. And this is something that wasn't possible, right? So if you were used to do something in one framework, when you go to the other framework, you would miss some features, gain some features. Now you get the best of everything. We call that the Keras Core. So the import Keras Core as Keras. Instead, remember I showed you import TensorFlow as Keras or something like that. So the idea is import Keras Core as Keras. And this is we are calling this the preview for Keras 3 because that's where Keras is going. And it's not only some changes, it's a full rewrite, right? We changed everything. It went from 135 lines of code to only 45. So there's a lot of stuff that was deleted. I guess when you can rewrite stuff, it makes sense, right? You make things better, faster. You know exactly what's going on. And you can, if you're a TensorFlow user, you can just replace tf.keras by this import. You can just import this and everything should just work. Let's take a look on one code that would work in every backend. So here you can see I'm doing something similar to what I just shown. Is a little bit different, but it's the same idea. I import Keras Core, and then I create a sequential model. This time it's an input, dense. So it's, and then I call summary. Summary just shows the parameters. And then I call the compile method. Remember, compile, where I define the optimizer, the add-on optimizer, and the loss there is the categorical cross entropy. This line is very, very similar to the other one. I was using a string to define loss and optimizer in the other slide. It's the same thing here. This is not really a change. It's the same. You can do both, right? Maybe I should change the other slide to be more concise with this. And then I call the fit method. There's the evaluate if you want to do evaluating. There's the predict to get predictions. All this model can be all this code. You can do this using any backend. And when I say any backend, is you can do all of that if you're a TensorFlow developer, a PyTorch developer, a JAX developer. You just define the backend as an environment variable, or we could define over there before the import Keras as Keras, you could say backend as TensorFlow, backend as PyTorch, whatever, and it would work exactly the same. And you could save something that could be used in any of these frameworks, right? So here, for example, we can go deeper. Here, I'm going to create a layer, right? A token and position embedding. I'm not going to go into explain details what that does. What I want you to pay attention is I'm creating the exact same layer in the three frameworks on PyTorch, JAX, and TensorFlow. And if you pay attention here, I'm creating the class. I'm subclassing keras.layer, and then I'm overriding the call method, and that enables me to use this layer on the Keras model. But the thing here I'm doing is, for example, let's do the PyTorch one. Online, I do def call, and then a comment, and then something, and then there's positions equal torch.arrange, right? That's a PyTorch method. It's a specific PyTorch. There's some others, torch.nn.functional embedding. There's another functional embedding down there, torch.sum, torch.square root. If we look at the TensorFlow one on the bottom, embedding lookup, other embedding lookup, sum, square root. So you can see that I'm using specific framework functions in a Keras layer, and these also work. I can use this on Keras Core, any of those, right? The problem is if I do this, then my model is framework specific. And then what I told you about being available in all frameworks will not work because I'm using very specific framework methods. And then the question is, okay, so how would I do exactly the same thing but keeping the framework agnostic, right? How can I do that? We bring with the Keras Core something called Keras Ops, which is a cross-framework list of components that you can use instead of the framework-specific ones. And of course, we have all the NumPy API, all the functions, same arguments. So you have ops, match mul, sum, stack stuff. We of course have the neural network specifics that are not on NumPy. So softmax, binary cross entropy, convolution, and you can build your layers using this, and this will be completely cross framework. Whatever you build with using Keras Core Ops can be used on any of the frameworks. And you can, for example, when you use if you want to use a custom loss metric optimizer, you can use that from the specific frameworks you want. We are going to see some examples of that. So all these Keras Ops can do is, if you, on this example here, so if we look a version that's completely agnostic, it's here. It's the same example I just showed, but using only Keras Ops. So if we look into the, let's skip the init, because we skipped the init on the other example. So let's go directly to the call here. You can see that, for example, there is a positions equals ops dot arrange. Ops is, of course, Keras Ops. Oh, there's a wrong import there. Sorry. No, that's correct. That's correct. It's just that I'm importing ops from Keras Core. And then I do ops.arrange. There's ops take at the bottom. The two last lines is ops.sum, ops.square root. These are the neural network operations or NumPy operations that are cross-framework. And then what you can do is, if you have any specific implementations of a layer, you replace your specific Torch, TensorFlow, JAX operations by these ones. And now your layer can work in any framework. And Keras has another thing that if you're a Keras user, you know that there's something called progressive disclosure of complexity. And the idea is that to do simple stuff, it's simple. And the more you need from the framework, the more you need to learn, the more you get from it. So you don't need, there's not a steep curve of learning that you have to learn a lot of stuff that you don't use at the beginning. You can start very slow, learning small steps. Those small steps always adding up to your knowledge until you get to very advanced things, but you don't need the advanced things to do the basic. That's the idea. So we have some examples of that. One example is when you train a model. So when you train a model, you have the fit method. I showed you fit method. When you call fit, model.fit, you start training the model. So training the model does a lot of things. It calculates laws, does the applies the gradients, does logging, sometimes saves checkpoints, all of this kind of thing. So the fit method does all of that for you, does the training loop, does everything you usually want as a basic, right? You don't need to do anything else. But if you need more from that, if you need, oh, no, I need my fit method to do more. I need to save extra logs, for example. Or I need the fit method to stop earlier. Like when I get to a specific loss level, I want the training to stop. So what you can do is you can create a series of callbacks, and you give these callbacks to the fit method. So the fit now you add an optional parameter, which is the callbacks, and it will change how the fit work, right? It can stop early, do early stopping on the training. But then you tell me, no, Gus, I want to do more. I want to have a control of each. I want to control the steps, the loss measure. Measure is fine. Yeah. How do I'll calculate the loss myself. I'll apply the gradients myself so I can change the training step. Oh, you want to change the training step? No problem. You can do that. You can still call the fit method and customize the training step yourself. We're going to see an example in a little bit. But then you say, no, guys, I am very advanced user, and I want to do the training loop myself by hand. I'm going to go over the data my way. I'm going to do the loss, all of this by hand myself, because I think I can do better. That's fine. You can do also that. But as you can see, if you are not an expert that can do the training loop by hand yourself, you can just call the fit method. And if you want to add more stuff, you can start adding step by step. It's the same thing for when you define a model. I've shown you two examples that use the sequential method, right? The sequential is just I add layers one after the other. That's it. But sometimes you need to create a model that has some indirections, right? You have to, instead of being a sequence directly, it's like more, I have more different path in my model. Or sometimes I have to have a loop. I go back to another layer from one other layer. So to build these kind of things, I have the functional method. I can do a functional way of building models. So this is more advanced, gives you more power. But then you say, no, I need one layer that's not available on Keras. I need something that I create. You can create your custom layers, and then you can use the custom layers with your functional API or the sequential API. There's no problem. But no, I need to go even deeper. I need to control more the model. So what you can do is you can subclass the Keras.model class, and you can change whatever you want there. You can change the how you initialize the model, how you do a training step, everything. So you can see that you can go from sequential, that's the most basic, to the most advanced where you customize everything. And this is why Keras is so good for students, beginners, and at the same time to Waymo engineers building self-driving car, right? So you see that the range of people that can use is everyone can use, is able to start learning and evolve from there. And we have also some integrations with all the backends. And here, for example, if you want to write your training loop using low-level jacks, like using the Optax optimizer, or playing with the jacks.grad, jacks.jit, or pmap, you can do that. You can define the model using Keras Core, and you do all these more close to the metal training things in jacks yourself. The trained model will still be cross-framework, right? The result will still be cross-framework. And you can also, if you want, you can do the same thing for TensorFlow and do the TF.gradient, take care of TF gradient tape and apply the gradients, laws and stuff. Very deep. You can do that. You can use TF distribute to distribute your training across multiple devices. You can do that, and the final model is still a Keras Core model that's cross-framework. And the same thing for PyTorch. You can call the Torch optimizer, a Torch loss function. You can do distributed data parallel from Torch. And the final model, again, still Keras Core compatible. And one cool thing is that the Keras layer, when you use the Torch backend, that's viewed as a Torch module. So you can put that in another PyTorch module, and it will behave as a PyTorch module, right? So this is very powerful. You can see here, I'm doing a custom training for PyTorch and TensorFlow. Yeah, the custom training here is not full custom training, right? I'm doing only the training step. So if you see, both are the same thing. These are the same things, except the training step. The training step, I'm doing specific per framework, of course. Doing a PyTorch training step is different from TensorFlow. This time I'm going to talk about TensorFlow. So the training step, you get the data, and then you, with the gradient tape, you call the loss function, you do the pred, call the loss function, and then you use the tape gradient to apply the gradients to your model. And then that's it. You do your training step over there. I'm not going to go into too much, calculate the loss. I don't want to go into much detail. This is deeper. But if you look down there, you create a model, custom training model, like the last 3 lines of the right code there. You create a model, custom training step model, blah, blah, blah. And then you compile, as we discussed before. You just call compile, and then you call fit. As you can see, the fit method, you train the model, but when it will do the training step, which you use your model's training step. Same thing for the PyTorch to the side. Same thing, so you can customize the training step. So give me a sec. Something changed. Oh, sorry. You can also go deeper. So this one is a training step. You can see training step. I can do also the training loop, which is more advanced. If you don't want to use the Keras.fit method to train your model, you can create the training loop yourself by hand, and that's what we are seeing here. I'm not going to talk about the training step because I've just discussed how to do the training step in the previous slide. But if you see at the bottom, the last 6 lines, what we're doing, we are iterating over your data and giving the data and doing a training step. We call the training step many times. That's basically one training loop there. And this is it. You customize the training loop by hand using the same model for both, using specific things for each of them. I'm not going to go into detail, but this is exactly the same thing using JAX. To do that in JAX is a little bit more verbose, I would say. There's some details here and there. I'm not going to enter into super details, but if you look at the first 3 lines, get model, define laws, optimizer, and we go here, it's the same thing for all 3 of them, right? Same thing. But then when you do the training step is a little bit different. When you do call the optimizer a little bit different, they do some things. One thing that's very important to pay attention here is JAX is stateless, right? So when you train the model, it doesn't keep state. You have to keep, if you need the state, you put the state as a variable, right? When you call. And the Keras Core API can work stateless. That's why it works with JAX. And you can see one example of that if you look, for example, when inside the training step, you can see that there's the state over there, right? You do something with data, and then it returns something, and then you have the state, and then you call optimizer.statelessApply. So what that will do is that will get your variables, and it will apply the optimizer and the gradients, but it will not change your model. It will give what would have changed, and then you use that to calculate other stuff. So it keeps things stateless as a JAX, the JAX paradigm would expect. And that's one of the advantages they have, but it's also harder to use. Anyway, this is a custom training loop. The other cool thing is, so Keras has always had like the applications package where you have access to many image classifiers, and you can load those from Keras.applications. I don't know, MobileNet or something like that, and you can use those easily. Those models are all of them now compatible with Keras Core. So you don't need to worry if they are all. So all of them work on all frameworks. And more than that, I guess you learn more about Keras CV and Keras NLP on Saturday, right? They have like pre-built models, all of them, like for example, YOLO V8, BERT, Opti, there's some others. All these models also are all Keras Core compatible already. So they work in any backend. They can work on JAX, TensorFlow, and PyTorch. So all these models, these pre-trained models that were available, all available in all frameworks. And one thing that's very new is that we are working on the distribute API. I'm not going to go into too much detail, but this is how you would train your model on many machines distributing data, or on many machines distributing the computation. So your model has different parts on different machines. This is, of course, if you're building a very large model that doesn't fit on the memory's accelerator's memory. This is, of course, if you do large language model modeling, this is one important thing for you. And as of today, we already have the JAX sharding for the JAX backend, and we are working on the PyTorch and the TensorFlow D-Tensor to bring the same power. So what will happen is that you can do distributed training using only the Keras Core API. We'll have the layout map, device mesh, and tensor layout. All of this will be available in Keras, so you won't need to go into deep specific framework code. This is coming. It's what's happening right now. This is some example code. As you can see, training a model distributed like this is way more verbose because you have to define much more things, right? Where you're going to put your data, where you're going to put parts of your model. So this is more complex, but we're working on that. There's a tutorial. You can take a look on how things are moving. And Sorry, this slide shouldn't be here. The idea is that you can use Keras to train your things with any custom backend, and you can use, of course, you can still use the specific distributed API for your specific backend. So you can use the JAX sharding by hand if you want. You can use TF distribute or dtensor, and you can use the PyTorch distribution API. I don't know exactly what it is. I don't know the name, sorry. Not an expert on PyTorch. But you can use all the native ones with a Keras Core module. We are just making easier for you to learn only one API. That's what that's happening here. And now the question is, okay, that's all cool and all, but why should you use it? Let's suppose you want to maximize performance. What you can do is you can define your model and you can debug your model in one backend that you prefer, that gives you the best errors. And then when you are ready, you can train on the faster one. So for example, you can play with your model until you're happy. And then you say, okay, now I'm going to send this for training for a couple of hours. You just change the backend to be JAX. It will probably be 20 times faster than the others, just by doing the backend. Same model, same everything. The other thing is, let's suppose you train your model, you prefer using PyTorch, whatever, right? Okay, use PyTorch backend. And then later, if you want to serve this model or deploy these on the browser, on a phone, you can just load the model, load the weights using the TensorFlow backend, save as a saved model, which is the TensorFlow saving file, and then you convert that to TF-Lite or TF-JS. That's it. Or say, no. I want to use the TensorFlow backend, but I need a tool from the PyTorch ecosystem. Okay. You can train your model, have the weights, and then when you need to use the tool, you can load the model on the PyTorch backend, and then use any PyTorch tool that you would, because that's a PyTorch model, right? Because you load as a PyTorch backend. Same thing for JAX, and then we solve one of the problems that we mentioned at the beginning, which is, should I go for the 60% of the market, 40% of the market? Doesn't matter. With this, you have access to all of them, all of this. So if you are creating models to share with people, creating Keras Core gives you already access to everyone. There's no framework lock-in. And the other cool thing is that if you want to train a model, one of the important parts is, of course, the data. How is the data used? If you use TensorFlow, you know TF data. If you use PyTorch, you know the PyTorch data loader, or you also know NumPy, Pandas. All of them work with Keras Core, all of them. So you don't need to, you can even use a PyTorch data loader while using a TensorFlow backend, and vice versa. You can use a TF data while use a PyTorch backend. So you can mix and match, that doesn't matter. And here's some anecdotal, some data that I can show you. So if you were a user from Atiano user in 2016, you kind of had to migrate to TensorFlow 1. And that was work, right? Had some work. If you were using Keras, you didn't need to do anything. 2019, it was the migration from TF1 to TF2. If you were using Keras, you didn't need to do anything. And now, if you are using TensorFlow, if you're using Keras as of today, and using TensorFlow 2, you get access to JAX and PyTorch for free, right? Very, very close to be free, right? Maybe you did some custom thing you had to update, but very, very close to be free. And this is the cool thing, right? This framework is frameworks keep coming and going, but Keras is still there, and that's one of the advantages. There's some resources here. The main resource, of course, the keras.io/Keras Core. There's a getting started notebook where you can play with everything I told you. In the site, you have more information. And before going to questions, one cool thing from Keras Core is that there's a lot of development going, and the community is helping a lot. If you go to the GitHub page, you see lots of people contributing code. So this is a great opportunity for anyone to come and contribute code, contribute documentation, contribute to the project, right? So if you are thinking about how do I work on the open source development, this is a great opportunity, right? And then you might end up interacting with Francois, which is the Keras creator, or any other nice people that are there, and learn from that. I've met a bunch of people that contribute. They are happy, they learn a lot, and that's a great opportunity. Thank you very much. And if you have questions, bring that in. And I'll leave my contact here just in case. Was it okay? Bring the questions.
Okay, it was good. Thank you so much, Goose, for that. We'll get you the questions. Of course, we have some questions on the chat, but we also have other questions on the form. So I'd like to invite Benia to start with the questions.
Hello, Gus. Awesome talk. This was been very enlightening. And the question is, what inspired the creation of the Keras framework, and how has its journey influenced the broader deep learning landscape?
Oh, that's a deeper question. So the idea is, if you develop software in the past, one thing that has been happening is that the APIs to whatever you're developing, they start to get easier, right? I developed software in the early 2000s, so I've seen stuff that I cannot understand today anymore, right? Because it was too complex. And then one thing that was, we need to make this easier so that everyone can achieve what they want. That was for regular software development. For machine learning, it was a similar problem, but even harder, because when we talk about machine learning, we are solving a harder problem, something that at some point you need to know a lot of math, a lot of algebra, a lot of stuff, statistics, and you need to know all of that, and coding, and. So it was hard. So the idea for Keras was, no, we need an easier API, something that people can at least take away the complexity of expressing what they want. Of course, the math part is still there, but if we can take away the how to express part, make that easy, that's basically the idea. And I think that that impacts a lot, because everyone starts to pay attention to, no. We need to make things easier for everyone. Even we think, researchers, researchers are developers like everyone else. So if we make their life easier, everyone wins, right? And that's the idea behind Keras, and that's why it's so important that it's available now in all frameworks. Because I don't want to use something, I can use the other. So I don't like to use PyTorch, I'm going to use TensorFlow, but now you have both. Or I have all this code already in TensorFlow, but I want to start using JAX. You can do that, same thing. So the idea that is now cross-framework makes everyone's life easier, gives tools to everyone. That's why it's so important, I would say. Questions?
I think you're on mute, Banya.
What are some key features that differentiate Keras from other deep learning frameworks, and how do these features benefit developers?
That's a good question. I guess the idea is that Keras is over them, if you look into like a hierarchy, right? So Keras is over TensorFlow. Keras uses the TensorFlow math and functions when it's the backend, but it's over it, right? So it's not just that the API is better, but in terms of the speed of execution, the operations is kind of very similar, because the layer is very thin, so it doesn't add too much overhead. Same thing for PyTorch, same thing for JAX, right? So the idea is that it's hard to find to whom it competes, because it's the idea is that it's above the frameworks, right? It's a layer over them. So it doesn't really compete with any of the three. Maybe if there's other modeling frameworks, what Keras brings is a framework that is compatible among all of them. And that's something that didn't exist, right? There's no other framework that works on all three ML frameworks that I discussed. And that's, I guess, the main thing here, right? And it's, I guess that's the win, right? Win for everyone. That's the idea.
Definitely are great news for
Yes,
all
exactly.
developers, right?
Yes.
Yeah.
Yes.
How has Kera evolved to support both engineers and advanced users, offering a balance between simplicity and flexibility?
So this is very hard because it needs to be part of the definition of the framework from the start, right? Because sometimes we target one specific user and then we go only for those kind of users. The problem is when you do that, if this kind of user evolves and have different needs, your framework may end up being obsolete. So when you look more broadly and you can have more users that can use your framework, it's better because even if they evolve, they can still use your framework. So if you target your framework for beginners, when they start to be too advanced, they'll drop you and use something else. Or and vice versa. If someone's too advanced and your framework is only for beginners, they might not use. So the idea that Keras target should be be easy when you're a beginner and give you the advanced features to for when you are more advanced to use it. That's the key. And this is a very hard architectural decision. And one thing that they do is they have very good defaults. Everything has, if you don't put anything, it will you can expect the most obvious defaults. You can customize many parts of the framework, like you can customize a layer, loss function optimizer, a module, or can customize basically everything. So this is an important thing for more advanced users where they want to create a different layer, right? Create a different architecture. So they have this power, and this is a very challenging architectural decision that I'm very glad they took into this account and create something that's can match your level, right? So if you're a beginner, you can use. If you're more advanced, you can use also.
Okay, so are there any limitations of Keras?
Limitations. I don't think there. So for TensorFlow user, right? And from my usage of Keras in all these years, I've never noticed anything that I say, I'm missing this here. What I notice is sometimes you try to do something that's not really the way of doing it. You study a little bit more, say, oh, I'm doing wrong here. I should have used, I don't know, a callback. So the main problems I found was because I didn't read the documentation properly. So I don't have any, there's this gap here, right? One thing that can be improved, and we are working on that, is the distributed API, because doing training in a distributed environment is very hard. It's the hardest thing you can do as of now. And we are improving the API to be easier. Today it works. You can use the native from each framework, but I think we can do better. We can do one unified API that explains. And then when we get there, it's like you don't need to go to the raw code for the framework. You can use only Keras. If you want, of course, you go in and do specific things by hand. But that's, I guess, the gap. No, it's not really a gap. It's just it will be easier. It will be even easier later. That's it.
Okay. So can you discuss some of the challenges and considerations in maintaining an user-friendly interface while supporting complex deep learning tasks?
It's, I guess, one important thing is when we review code it's been committed, we have to always keep in mind this principle of, is this still easy to use? And that's why defining a new API or something takes more time, because you have to do some talk to people. Because the problem is, let's suppose I'm a beginner today, right? After a while, I do keep doing stuff. I am not a beginner anymore. So it might be hard for me to see something as a beginner because I'm not a beginner anymore. And when you do more, you get advanced. And then the advanced users say, oh, no, you can define an API like this and it's easy. No, it's easy for the advanced user, right? how do you see the things as a beginner? This is a lot where the community can help, right? And contributing, stating your opinion. But it's a hard one. We try to do the best possible. That's why it's incremental. There's always a place for people to talk about it, report bugs and stuff like that, because this is not trivial, right? So this is something that we are always looking for.
Thank you. And we have folks using scikit-learn. How can they switch to Keras? And what benefits do they get when they do so?
So that's an important question. So people using scikit-learn, they have scikit-learn is another framework, right? But they are they're more broad, I would say, because you can do a lot of stuff using scikit-learn, not only neural networks. And this Keras Core specifically is focused on neural networks. And if you need to do something that's more advanced, or even it doesn't need to be advanced, but more that use all hardware, can be distributed, served, and many other things, scikit-learn will not give you that, because their focus is not to be like to do neural networks. They do everything, including neural networks. And so that's, I guess, one of the advantages of Keras being focused on neural networks. We have also an API for decision forests with TensorFlow decision forests, but they are different, right? They're different things. They talk to each other, but they're different. And I would say for scikit-learn person, I think it would be a good opportunity to learn, since the API is very fresh, right? Although the API is similar to what we had TensorFlow, but it's a good moment to learn and be able to stretch your wings, I would say, like that, and be able to access something. Of course, scikit-learn is very important. It's if you know that, you know a very good framework, but it has its limitations. And if you want to go more production distribution, Keras will do better. So that's. But I strongly suggest you learn both of them.
Yes, for sure. That's a great advice. And now we are going to go back to Gesa for the Keras Core questions.
Oh, sure.
Thank you, Banya, and thank you for answering those questions. So we've had TensorFlow 1, and then came TensorFlow 2.0, and with all of them, we've been having Keras running on top of them. So now that Keras is becoming multi-backend, what's the future of Keras in TensorFlow?
That's a good question. So the idea is to make everyone's life easier. Keras is evolving, of course, as a API. TensorFlow keeps evolving because there's still a lot of challenge on training a model, making things faster. And TensorFlow is more than just the core part of making the math. It's also deploy on a mobile, deploy on the browser, serving, having a pipeline for training stuff with TFX, many tools, right? Doing decision forests, doing graph neural networks. There's a lot of stuff below this level that are still very important. So there's still a lot of development to be done, and that will continue. But now the idea is to make easy for people to maybe come to the TensorFlow ecosystem. If you're doing something and you want to use TensorFlow tools, it's easier now. So you just need to use the same modeling language, let's say, like that would be Keras. So that's an opportunity to have for everyone. And since we see this siloed thing is not great for science, right? We have something there written PyTorch, and sometimes I'm a TensorFlow user. I want to use, it's annoying, blah blah blah. Now it will be better. So we're talking to people to adopt. It depends on people adopting, of course. But I think it's a win for everyone. So that's the idea. Is Keras still has lots of to improve, other features like the distributed API I told you, and TensorFlow also has a lot to evolve. There's some new loss function, new optimizer, new techniques that can be developed that can be used later by Keras Core. So there's still a lot of development to come for both of them.
Okay, thank you for that. So today we have some developers who are using PyTorch, and they're comfortable using that PyTorch. Also on this other side, we also have developers who are used to using Keras and TensorFlow. So why will someone who is using PyTorch switch to, for example, PyTorch with Keras? Or someone who's using Keras and TensorFlow switch again to PyTorch?
That's a good question. For the TensorFlow switch to PyTorch, technically you don't need to switch anything. But if you want to use a specific PyTorch tool, you can, if your model is a Keras Core. So for TensorFlow Keras, people, that's an easy, I can just use the tool or a technique or something like that. From the PyTorch perspective, if you want to share your work with more people, increase the reach of your work, that's a no-brainer, right? You can still keep using PyTorch as the backend, all your tools will work, but you define the model using Keras Core, and that's it. And your code now is working any framework, and you buy with that you gain converting model to run on the browser, or serving with TF serving, or everything related to all the TensorFlow tooling, which is the powerful part, right? Deployment and tooling of TensorFlow is very, very strong. So you can, if you're a PyTorch developer, if you just change how you define the model, which is not like such a big change, right? Maybe you change by the Keras ops I mentioned before. You can do step by step. You never lose anything. All of a sudden, your things are compatible with all the frameworks. And I think that's, and the other thing is, if you want to train models faster, you can just have your model train your stuff using PyTorch backend until you're happy. And then when you want to, I want to train this as fast as possible, you just change the backend. Poof, change, and it will train 20% faster. So there is a clear win there. So you can train stuff faster, inference is faster because of many compilation steps that JAX and TensorFlow have. So this is a win by itself, right? Just if you need to use less resources, train faster, instead of paying for a machine for 24 hours, you pay for only, 18 hours. That's a win, right? So that's one of the main things you could think of.
Yeah. So also someone is saying that we've seen that you're having some custom training loops on the slides. And it seems that now you can do custom training loops both in JAX, PyTorch, and TensorFlow. Does it mean that now you can even probably see how the custom training loops works in JAX, then compare it with PyTorch and TensorFlow, then see the best one to work with?
You can do that. One thing that have to have in mind is, for example, if I choose PyTorch as backend at the beginning, then when Keras is doing stuff, it's thinking it's in PyTorch. So if you try to do a training loop in JAX, it will not work, right? Of course. But you can use the custom training loop to see what's the best way of doing stuff, right? The best way you feel like doing. You cannot mix, of course, and match this. But the important thing is, whatever, doesn't matter whichever training loop you use, what you have in the end, the Keras model is compatible across all frameworks. The only thing that doesn't make it compatible is if you use inside a layer specific framework operations that you should have replaced by the Keras ops ones. That's it.
Okay, thank you for that. Also, we've seen that you support a range of backends. You support JAX, you support PyTorch, and you support TensorFlow. And we've also seen NumPy on your slides. How comes NumPy is just used for inferencing only, but not for what the others that the others are doing as well?
Yeah, so the NumPy backend is mainly for testing a concept. We wouldn't suggest use that for anything like serious, like professional. It's mainly for the test. You can replace the backend and it will still work because NumPy can do. JAX technically is kind of a NumPy, right? JAX by itself is a mathematical library, right? It doesn't do. It's not a neural network, it's a mathematical library. So it's very similar to NumPy in terms of that. The idea that NumPy can be replaced as a backend is similar, but it's mainly for testing purposes. It's not something we incentivize, let's say like that.
Awesome.
Someone's calling.
Yeah. All right. Then also we've seen we've seen people using TensorFlow, and they're using TensorFlow because they like Keras. And we've also seen other people who are using PyTorch, but they're saying that what they missed most about what they're really missing most is the Keras part of it. So some people are saying I don't want to use PyTorch because I like or what I'm really missing when I'm using PyTorch is the Keras. So does the Keras Core bring an end to all this?
I think so. You can. It makes easier for you to define your module, like define the modeling part, which is one big important part, of course. So you can do with any of those backends, and of course, if you the thing is, if you don't like one of the frameworks, you just don't use it. That's you don't need to use it. That's the important thing. But if you can use any of the other two or whatever you can do. So this is, I guess, it's a win for anyone trying. I'm being very honest. I don't see any drawbacks, like something that say, yeah, there's a catch here. I don't see that. I've played around, tried. It's just a win. That's my take as of today.
All right. Thank you for the answers on Keras Core. I'll now hand it over to Daisy to ask us more questions on community and collaboration. Daisy.
Thank you very much, Ngesa and Goose. So for the community, I mean, the community is a very big part of this to make sure that whatever is getting churned out of Keras is actually implemented and that people have a rich understanding. So I'm just keen to understand what role the Keras community has played in the growth and evolution of the framework, and how can newcomers get involved going forward?
That's a good question. Very good question. So the development of Keras Core is on GitHub, right? And they just moved to another GitHub handle these days. So if you go on find the Keras Core GitHub, it's there. It's easy. Just follow the README, and it's all developed there. So you can see what people are, all the pull requests happening. You can ask questions to the community there. There's a lot of people contributing, which is great. It's something I'm very excited to see how many people are coming to make this better framework for everyone. And I was looking to that today before, of course, presenting. I was looking at what was new. And there's a lot of changes. If you look at the last video, there's a lot of changes from people that are not from Google, right? There are a lot of people, which is a win, right? It's a great opportunity. It's very hot, they say, right? Lots of people doing stuff. So it's a great opportunity for you to grow with the framework, grow your career contributing. If I were now I'm starting, I want to do some cool stuff. That's a great opportunity to be there to do this. And I see there was a lot of hype on machine learning, a lot of repositories doing some stuff that with many stars, and you say, what are they doing? And it was always intriguing me. But Keras Core is when I look and I understand. Look, I know exactly what they're doing. I know why this is for. I know this is important. So batching on this is obvious, right? It's just I know where it's going, right? It's something that's core. So I would strongly recommend the documentation. They have the Keras.io documentation site. They have, I guess, guidelines for contributing there. You can contribute many things, not only if you don't know how to do the coding ops and stuff. You can contribute a tutorial, and that's a win, right? You contribute, your name will be there. It's good for if you think about, oh, what work did you do? Here, contributed this to Keras.io. That's already something.
Thank you, Gus. I really like that. Along growing with the framework and growing within the community that's actually building that, and I believe that would be a good opportunity to contribute to open source. So just on top of that, what further support is the Keras community doing in terms of, say, resources and other learning materials?
That's a good question. So the Keras.io/Keras Core is where most of the documentation is going. There's a lot of people doing trainings. People from I see some people giving this kind of talk I gave you I know them because they help build Keras Core from the community perspective, right? That's how I know them. And so this is great because you can talk to these people if they're in your region, right? I'm far from you, but maybe there's someone in your region that you can talk to. Far meaning in distance, right? We can always send emails, but the people go to an event in person, they are there, you can talk to them. So this there's a lot going on. In terms of documentation, I think it's going really well. Sometimes stuff evolves and the documentation is lags behind. The documentation here, as far as I can see, it's doing great. You can do tutorials, everything's working. So I think what I would do is go to the keras.io/Keras Core. This link here. Let me try to see if I know the right link. Yeah, keras.io/Keras_core. Yes, the first one. Go there, read the docs, understand the basics. If you're already TensorFlow user, you understand very quickly. It's basically the same thing. If you're a PyTorch user, then you have to maybe study a little bit more because it's a little bit different from how you define a model. Same thing for JAX. But I would say it's very similar to how I learned Keras. So when I was a beginner, I liked the way it was framed. So that's why I think it's still the way is good to learn.
Thank you. Thank you for that, Goose. Just along the same veins, this would also just be to encourage a beginner who's starting out in terms of open source contributions. So what would you say are some of the most impactful user contributions or community-driven projects that have enriched the Keras ecosystem?
I see a lot of stuff going on, not only in the Keras Core repository, right? People go contribute. That's one. I see people building applications using a Keras model, like you do your GitHub and let me use this model to, I don't know, predict pets, I don't know, something like that. So in terms of community contribution, there's a lot of stuff that can be done. And having your own small project, it's one. Contributing on someone else's project is another. Giving talks in events like this is community contribution. That's everyone wins. I started before becoming a DevRel. I gave lots of talks in communities like this. There were Android talks back then, well, not machine learning, and you learn so much by going to an event, talking to people, giving a presentation, studying for a presentation, putting a presentation in place. This is something that you do because you like, right? When you do at your job, it's different. You're being paid, blah, 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 your boss. When you go to a community, people are not going to judge you. They're going to help you. They're there to support you. So it's a different environment. So I would strongly suggest, if you can, go give a talk, create a project, create a blog, a tutorial. There's a lot of stuff that you can do to contribute. And then you ask, why would I do that, right? I can just play Spider-Man, right? Turn on PlayStation, play Spider-Man. First of all, you can do both. But when you do that, you are learning something and you are creating a portfolio that you can later show. Oh, you're going to interview somewhere. Oh, by the way, this is my GitHub link. And then people maybe might look there and say, oh, nice. There's a lot of cool stuff here. Oh, this person contribute here. So, and more than that, when you start to be more frequent contributing to stuff, I know a lot of people that received job offers because they are contributing to a project. And then first, well, who are going to hire? I don't know. Who is contributing to this tool? Oh, let's talk to them. That we need someone that knows this, or you're contributing, you know this. And I met many people from the community, that I know them because they did many tutorials, many notebooks and stuff. And that's just great, right? That's a way of entering the field, knowing people, meeting people, improving what you know, becoming a better professional. So being part of the community is like a superpower. When you do that properly, you get a lot of I would say leverage. It's it's very, very important. I should have started doing this earlier. Although I've been doing this for more than 10 years, but I should have started doing this earlier. And if you're a beginner, start doing this. Go to an event and talk to people. Yeah, if you're here watching this talk, you're kind of in the right path because you're watching a community event. Keep doing this. Next time, maybe you are presenting, right? That's how things work.
Thank you, Gus. As we close on community, I'm just keen to understand how Keras fosters collaboration between researchers, practitioners, and developers to collectively advance deep learning and AI.
That's a good question. So one of the things about being multi-backend or multi-frameworks is this to bring research closer to the builders, right? People like, I want to build something. Oh, but I've been playing with TensorFlow and the model these people built are in PyTorch, and now I have to learn a lot of other stuff. If everyone is doing a same framework, my perspective is different now. Now I see, oh, there's this research I can use with the tools I know already. Nice, let me just try. And then a researcher that spent a lot of time creating a beautiful model to do X, Y, and Z, now it impacts more people because there's more people that can access it, right? Is how do I say? It's like creating an easy way to interact with more people, right? It's like if everyone speaks the same language, and then it's much easier for people that are starting or that have for Android developers. I was an Android developer, right? I'm not a wasn't a machine learning expert. So if I'm going to start using some models from someone, I have to learn a lot of stuff. If every time I need to learn a new framework, a new tool, a new something, I'll just give up. And then research cannot connect to builders, right? So if we are all at least using something similar, it's easy for me to leverage that research, to share, to learn, oh, you did a new way to calculate loss. Oh, let me see. Oh, I can understand what you wrote here easily. Maybe I can use that. So that makes research also more useful to everyone. So I guess that's being cross framework. It's very, very powerful.
Thank you, Gus. And finally, you could just share with us what you love about Keras and if there's anything you'd really change about it.
So I was already a TensorFlow developer. So when Keras Core came, nothing much changed because I was, oh, nice. I got more stuff. I can train on JAX easily here now. And that was something that I'm not a strong JAX developer. So the fact that I can take my stuff to JAX and play with that there and see stuff train faster or play with it in easier, like that was a good thing. One cool thing I do sometimes is I go in the tutorial in the Keras IO thing, and what I do is I go into the new notebooks that people contributed and see what people did. Oh, let me see. Oh, there's a tutorial to do X, Y, Z. I go over the tutorial to learn something new. So this is something I do quite often because people put a lot of work to do very beautiful notebooks. And that's so amazing because you go there, read, learn something, you can play the code, you can run the code on Colab, and it's like you just learn. Just easy. So I keep learning something. I learned a lot from those tutorials, by the way. And some are like I had to do more than once to understand. But that's the idea, right? You can stay there learning, keep playing. So this is, I guess, one of the secret tips. Go do the tutorials or that people put there, right? Those are amazing. Oh, if you want to, I can ask for the Flax question. I don't know. That's a good question. I don't know. Because technically, Flax is on the same level as Keras, right? When you talk about Flax is a way to define a model. I never used, so I don't know if it's good or bad. I don't have an opinion. The problem is that Flax is a JAX-specific framework, right? It's completely JAX-specific. I don't know what will happen. Maybe they merge what's best for Flax with Keras. I don't really know. That's a good question. I don't have an answer for that.
Okay, all right. So thank you for that. It was really exciting. We really learned a lot. Thank you so much for the great session. And
Of
also
course.
thank you, Bania and Daisy, for the questions. It's been amazing. And also, I'd want to thank all our attendees who have tuned in from different parts of the country and even from outside Kenya. Thank you so much for joining, and thank you so much for sending us the questions. I can see that it's already 9:10. We're 10 minutes past 9 p.m. and we'd want to close it at this point. So have a wonderful evening. Until next time.
Bye, everyone.
Thank you. Bye.
Bye. Thank you so much.
Bye.